Once we trim the aircraft, we can define the initial conditions to be the trim values. So that will be your initial conditions. But now that you have your initial conditions, we can give some pilot inputs and run some quick simulations within Heli-Dyn. So let's give an example. I had trimmed the aircraft at hover, and what I will do is I will I define the initial conditions to be the hover conditions. So I go to pilot inputs, and let's say I want to give some step inputs, some classic step inputs to look at the initial response. So this is pretty straightforward here in Heli-Dyn as well. We have here 4 boxes. We have collective control, longitudinal control, lateral cyclic control, and a pedal control. Let's say we would like to give some step inputs for the longitudinal cyclic. Now note that we have, so you just click on this and you have a keep initial conditions tab. So that will be the, it will keep it there forever. So note that everything else has keep initial conditions. So if you click on this, now it's no more initial conditions. Now it's our turn to input some of these numbers. So let's say from 0 to 1 second, I'm giving no inputs. So 0, I say simply add. So this will be then the value at the trim condition, longitudinal cyclic trim condition. Right? From 0 to 1 seconds, I have the trim condition on longitudinal cyclic. And note that everything else has already its initial condition. Right? So let's go from 1 to, let's say 3 degrees. Let's give 3 degrees, let's do this, 3 degrees of a cyclic input. Now from 1 to 3 degrees, from 1 to 3 seconds, I have an additional 3 degrees of longitudinal cyclic. And let's say from 3 to 4 seconds, let's reverse this and let's say I have a minus 3 degrees, add. So in that case, the longitudinal cyclic control, the swatch plate control was at minus 0.81, which was the trim point. From 1 to 3 seconds, I have an angle of 2.1 degrees. That would be the longitudinal cyclic control input. And from 3 to 4 seconds, it's back to its trim point. So basically between 1 and 3 seconds, for 2 seconds, I have a step input of 2.18 degrees. Everything else, pedal, lateral, collective, they are all at their initial trim points. So I can't go back to my simulation now. This is my simulation window. The simulation duration here is 6 seconds, and my time step for my simulation is 100 Hertz, 0.01 seconds. So on this other side, I have all my variables I can see and plot and get as an output. For example, let's plot the attitudes. Basically the roll, pitch, and yaw angles. I right click, I say plot, and here I will be able to plot it in a second after I run my simulation. Let's also take the body XYZ velocities as an example and plot those. These are the velocities. And maybe I also want to plot my controls, the commanded controls. Let's plot the maybe all 4 of them, collective, lateral, longitudinal, and pedal, and say plot. So I will also see and make sure I gave the correct outputs here. All I need to do is now say run, and the simulation starts running. Note that from 0 to 1 second I had nothing. Right? So everything was at trim. Look at the attitudes. These are the theta, phi, and psi angles. The green one here is the theta angle. So I have a huge nose down movement, and my phi and my yaw, they're pretty much constant. Here these are my body velocities. The blue one would be the x velocity. So I'm basically going forward. If you're confused which one is which, you can see here VA1 is the blue one and you can go back here and check what VA1 was, and VA1 says body x-axis velocity. It's in feet per second. Okay, it's in feet per second. You can always check these numbers over here. And our controls, well, collective is constant as its trim value, pedal is constant at its trim value, lateral cyclic is constant, but the longitudinal cyclic, here is our 3 degrees of longitudinal cyclic input, and these are your results. You can again print and save these images and see the response of the aircraft. Now, if you're interested and you don't only want to plot, but you also want to get this as a data, you can simply go to this console symbols, and now you can click on these variables. XC4, 5, 6 were the attitudes, and here we have the let's say you want to have the body velocities, right? And you simply say save text as output. So you will say in this case, let's say my data. It will save it under Heli-Dyn, and you simply say save, and that's where your simulation will be will save all this data, right? You say running simulation, 100% complete, and everything is back in my data file. Another thing you can do is we have this little button here, it's called console. So you press on this console here, and all the variables you select on this console here, right, they will appear here as well. Okay, let's say in this case we are not interested in the body velocities, but we are interested in the earth fixed frame or the navigation frame, navigation axis system, north east down velocities. So you simply say run, and it will run in this console for 6 seconds, and you have everything else. Now if you want to save this thing, as I said, you just say save text output, save text output, and you will say my data 2, save, and everything is saved into that data file. So if you want to plot this now in another third-party computer program like Excel or MATLAB or Simulink, you can just use this data to plot it there or do whatever you want with this data. And what the data you can plot here, everything, almost everything you have in the simulation is here as appears here as a variable. You have the velocities in different axis systems. You have things like thrust, inflow, tip path plane angles. You have the tail rotor thrust. You have position. You have the Euler angles. All sorts of velocities, accelerations, control inputs. Those are the things you can plot and get as an output to the symbols. For example, you might want to run a longer simulation, or you might want to change the step size. I mean, 100 hertz is a decent step size, but there might be cases where you want to run this at a smaller simulation step size. You have all access to these things, and this is just running a simulation. Now, an interesting thing here, an interesting application is with these step inputs, you might want to wonder what would happen if I would make the main rotor, let's say radius 2 feet smaller, okay, not 24 feet, but let's have it 22 feet. What would my simulation look like? You just press this, plot, let's say, and you can make the same simulation. Let's run this again at 6 seconds and say run. Now we are running the same aircraft with a shorter rotor. Now, of course, the helicopter is no more a trim, but with this input, you would immediately see what the helicopter would do at that particular rotor radius. Or another thing would be, what would the helicopter do if I had, let's say, if the gravity was different, or if the air density was a little different. Let's say I'm running at really low air densities. Simulation, again, let's try to run the attitudes, plot, and there you go. You can simply run this, and you immediately change the density, and you have the same step inputs, and you're running a simulation with a totally different density. So it is as simple as that. So this gives us a lot of flexibility in playing around with these different models. One of the features we have is to run pilot simulations with various pilot inputs. One of them is step input. Another one is a ramp input. We can give a ramp input. Another one is a sinusoidal input. Here I can define the start time, the end time, the amplitude, and the period of my sinusoidal input. And that, for example, could be applied, let's say, to a lateral control, right? We just say simple, a sinusoidal input from 0 to 4 degrees, amplitude 1 degrees, and the period, let's say, is 3 degrees. So you simply say add, and here it is. From 0 to 4 degrees, we'll have the starting point will be minus 2.8, that's the trim point, and the amplitude will be 1 degrees, and the period will be 3 seconds. So you just simply go here, and you play attitudes. Let's look at the Euler angles. Sorry. And let's look at the controls. Right? Plot. So if you look at those things, and let's immediately look at the simulation. We have the step input for the longitudinal cyclic, which I inputted recently, and I have my sinusoidal input from 0 to 4 seconds with my 3-second period of my simulation. So I can run a bunch of different simulations here. Another one that might be quite useful is the custom input, Bros custom input. So here you can actually write these pilot inputs as a text file. Okay, in this case I don't really have a file now, but you can have a text file where you define these numbers as a text file. The format of the text file is given in the help document. There you can check that. So in case let's say you flew a helicopter, and let's say you have some data and you want to run the model with the input that's been used, let's say in a flight test. So you put this as a custom input into Heli-Dyn. You run a simulation. In that case, it will simply run the simulation that uses the input that comes from your custom input text file. So that's another nice feature we use. So and that's the simulation capability that you can do within Heli-Dyn.